About heights and distances, I this is my duty to inform you that please go through the content on trigonometry in this course only. Okay, in this course, I have prepared the content for trigonometry in which I have introduced all the angles, like all the trigonometric ratios like sine theta, cos theta, and what is the relationship between the angles and the sides of a right angle triangle. Okay, so in order to go to heights and distances, because heights and distances what? Height is what? Height is perpendicular thing. Distance is what? Distance is the horizontal thing. So perpendicular and horizontal. If we join the tips of the both and connect the base of the both, we will form a right angle triangle only. So there are going to be a lot of angles and ratios. Okay. So please visit trigonometry first. Now why specifically heights and distances? See, you know trigonometry deals with the sides and the angles of the right angle triangle. Heights and distances often referred to as perpendicular and base, respectively, which means working on heights and distances, we can work on trigonometry applications. Okay, like this. See, suppose I say that uh, find the angle at which I am looking. I am standing over here. Find the angle at which I am looking. If I am, if I am, quote, if I am 15 meters far from a building, find the angle at which I am looking to the top of the building. If the building height is, if the building height is 15 meters and the distance between me and building is 25 meters. So this is building, this is top of the building, and this is me. Now at which angle I am looking? So in order to find out the angle, it means that if I am looking at the top of the angle, the line of my eyesight will be connected to the top. Yes. So this arrangement has made a unintentional right angle over here. Can you guys agree with me? Because obviously height of the building, it is not the leaning tower of Pisa. So the height of the building and the base, which is the horizontal flat ground, flat surface, they are making 90-degree angles. And at which angle I am looking? Let me, I am looking at an angle of theta. Now you know what happens. We have perpendicular, we have base. Now what can we do to find out theta? What is the trigonometry ratio that consists of both perpendicular and base? Tan theta. Tan theta is equal to perpendicular upon base 15 by 25, 5, 3, or theta is equal to what we call it? Tan inverse 3 by 5. Okay, tan inverse 3 by 5. This is the way how to write it. So heights and distances provide us a lot of applications, and uh, like in plane, when the pilot flies a plane, suppose these are very much real world applications actually. Suppose plane is here at this point. Now plane has to land on a runway. Now runway is here. Okay, no, I have runway is very close. Okay, runway is here. This is runway, starting point of runway. Plane is here. Okay. Now the thing is, plane must incline towards the runway. It should make an angle of depreciation. Angle of depreciation means if this is the horizontal line, then there should be a dip in the angle theta. Dip in the angle theta in order to land to the runway. Now, how will this theta be calculated? It will be calculated on the current position of the plane from the runway and height of the plane. Current position of plane from the runway is what? Perpendicular distance from runway to the position at which the plane is there. This is the perpendicular distance. Yes or no? Yes. I'm not talking about this. I am not talking about this. I'm talking about how far is the runway from the plane on a horizontal plane, on horizontal axis, and other is height of the plane. This. Now tell me, this is the height, this is the distance, perpendicular distance. Okay. Now plane has to take a dip. Now when plane takes a dip, he will ensure that the plane's line of sight is exactly matching with the runway. Right? So now the angle that plane has to by which plane has to dip in order to lag at the runway is theta. Now this is horizontal line. This is also horizontal line. It means both the lines are parallel. So the Z formation is there. So if this angle is theta, this angle is also theta. Okay. By rule of alternate angles. Two lines are parallel, one line is cutting them. Then this is a Z shape formation. This, if this is theta, this angle will also be theta. If this is x, then this angle will also be x. Okay, I have explained to you guys in the chapter parallelogram. Okay, now everything is coming together. So there might be some prerequisites. You go to the parallelogram chapter, I have explained that there. Now, what is theta over here? What is tan theta? We have two very known things with us: height and distance. Okay, what is tan theta? Height divided by distance, or theta is equal to tan inverse height by distance. So this is how the real world applications work. Okay. Now we will move to the problems part. All right. First, the shadow of a tower standing on a level ground is found to be 40-meter longer when the sun's altitude is 30 degrees than when it is 60 degrees. Find the height of the tower. All right, no worries. Okay. Now he's saying that there is a tower. So this is a tower. Now there is no chance that the shadow is being formed. Shadow is being formed on what? On surface, the ground. So definitely the sun will be above the tower for sure. And when the altitude, what does it say? It is saying that when the sun's altitude is 30 degree, the shadow is 40 meter longer than when it is 60 degrees, which means that there must be a shadow formation. There must be a shadow formation when the sun's altitude is 60 degrees, right? So let the length of the shadow when the sun's altitude is 60 degree be x, and there will be definitely a shadow when the sun's altitude is 30 degrees. So let the length of the shadow when the sun's altitude is 30 degrees is y. Now y is 40 meters larger than x. This is what it is saying. The sun's altitude is 30 degrees. 30 degrees from what? That is the question. 30 degrees from what? From the tip of the tar. Sorry, 60 degrees from the tip of the tar. This is the sun